DSRP is universal to all systems thinking, and metamaps offer a simple but effective template for visual clarity using these principles. The adaptive nature of metamaps is based on the user's ability to mix and match and combine and recombine these basic visual elements.
Now imagine that, like Lego bricks, these 4 simple DSRP rules can be combined and recombined in infinite ways. For example, the distinctions rule and the systems rule could be combined to make a new thing that is also part of an existing part-whole system.
There's no limit to what you're allowed to do with these 4 DSRP rules and their visual representations. As another example, we could take the whole with 2 parts, one of which has a part, and combine it with a relationship to get a distinctive and part-whole relationship between 2 things. So in this case, our end product might be the relationship between biology and chemistry, which makes up biochemistry, a new discipline, itself made up of parts. Or alternatively, you could think of the relationship as a multifaceted conflict between 2 countries. And any one of the objects in any map can be the point or view of a perspective, which can be mixed and matched. This figure illustrates how the result of our last combination can be combined with the perspective rule to create something totally new. In this case, we could think of this map as representing the very different perspectives of Palestine and Israel on the complex, multifaceted relationship between them.
Let's do one more. Apply the relationship rule to the parts of a whole, and you can get a system of interrelated parts. This could represent the related parts of a social group, a truck, or an actual ecosystem. Anything that has a bunch of interrelated parts.
And so systems thinking requires little more than practice in building with these cognitive building blocks of D, S, R, and P. It is really no different than building with 4 different types of Lego, or 4 different nucleotides, or 4 base colors. Mix and match, combine and recombine. Have fun. There's an infinite number of thoughts you can think and systems to explore. But these simple rules and the visual tools we've outlined here make it easy to visually represent any system, no matter how complex it might be.